Okay. So as most of you know, I've been working on protecting RPC and NFS in transit traffic with TLS, Transport Layer Security. TLS provides both encryption of content on the wire, and it also provides authentication of the communicating peers. And so we are hoping to bring that to NFS as something that is simpler to deploy and administer than, say, Kerberos, and takes us a step up from OffSys. So there have been, as we've rolled this out, there have been some comments that people would like a little more, they would like the servers to make a little more use of the client peer identities that are provided, because during the handshake, the TLS handshake, the clients send, if the server requests, the clients send over certificate, either their X509 certificate or some portion thereof that the server can then digest and use for authentication and authorization. So this is kind of what I've been up to here. My prototype, an idea that Ben had, and then some others went, yeah, that sounds like a good idea. And so the slides here are going to describe what I did, how it works, how what the administrative interface might look like, and some of the performance and usability issues are. And I just want to say that, well, the last bullet point is probably the most important here. It's a disclaimer that whatever I present today is flexible and can be adjusted quite a bit depending on feedback. And I'm hoping this is going to be fairly interactive, so that we can sort of hammer this out and I can get it actually merged into the software instead of thinking around with it for another 6 months. So traditionally, NFSD has had these per export controls, where you could specify one or more IP addresses or DNS host names or net groups, and specify that this export is can be accessed by that group of client peers. So when NFSD recognizes a connecting client by IP or host name, it permits access by that client. And then the normal user authorization takes place POSIX style. But it's just another gateway for clients, for service recognized clients as trusted or not trusted. This user interface was in Etsy exports, and then later in Etsy exports.d. But it hasn't really changed much over the years. What has changed really is that there are these IP address spoofing attacks. Basically hosts that are on the server's local area network can pollute its ARP cache and pretend to be other clients. So it's pretty easy to work around this IP-based access control. And of course, DNS is known not to be secure at all. There are plenty of efforts to make DNS a more secure protocol by protecting it with TLS or HTTPS or in other ways, DNS, SAC, et cetera. So that's sort of the problem statement, if you will. What TLS brings to the table is the ability to protect the in-transit traffic, as I mentioned. but it also allows the peers, the client, the server to authenticate each other. Either the client can say, I'm not telling you who I am, and the server can say, well, I can allow you to access or not, unless you have a certificate to show me, in which case then it can authenticate the client as well. So the questions come up more than once. Is there a way of leveraging this authentication capability in TLS to supplement or even replace the traditional IP and host name based access control that we have lived with in NFSP for 25 or maybe even 30 years? And we think the answer is yes. So we would probably add this new capability as new export options. And this slide kind of describes, you know, in abstract how we would add this support. We can either add it as new options, or we can add it as new options and take away the old ones. I think taking away the old ones might be a little aggressive, but the old ones aren't secure, as I pointed out before, and so that would be a reason why we might want to deprecate them over time. So some things came up while I was working on this. As I worked on this, I recognized that there are some things that, you know, the folks in this room might be concerned about as I was developing it. There are X509 is complicated. It's quite a pile of Legos to work with. The TLS libraries user space are also complicated, and we kind of don't want to, I don't want to use a term like pollute, but we don't want to have to put those, you know, dependencies into NFS utils, and especially not into the kernel. I mean, we have TLS HD on purpose. It's because the kernel folks just said we don't want that crap in the kernel. So that's one concern. We need to silo this a little bit. So we need to draw some architectural lines around, you know, what part knows, you know, has expertise to deal with which parts of this problem that we're trying to deal with. I recognized kind of quickly that if we're using individual tags and we're trying to put these tags on sessions, we're going to quickly run into an n squared or n cubed problem when every time we do a handshake. You know, the number of clients times the number of tags that the server knows about times the number of tags on an export, it grows very quickly. So there's immediately there's an issue with how this is going to perform at scale. I haven't solved this problem yet. I've been talking to some people who have some expertise with data structures to understand, you know, is there a way that we can build a data structure in the kernel where we can put both the export settings and the tags that we've set up to make it quick per session when we're dealing with a handshake, so that it doesn't really slow down connection processing. But that's an ongoing concern. And the third bullet point, it's been pointed out that there are other players besides X509 who might be interested in this level of access control on either NFS resources or maybe something else. So TLS certainly does support pre-shared keys. We don't really, I built something that was X509 centric, but maybe the PSK folks would also be interested in having some way of managing per client authorization of resources. We're also thinking, you know, what if we could do this for Kerberos as well? We've never done that. Kerberos has always been a per user thing, not a per client thing. But it's certainly possible to add some support maybe for making an FSD sensitive to what client is talking to us and using the Kerberos authentication as an authorization. I haven't really traveled down that path very far, but that's an open. So what Ben's idea is that what we can do is define these tags, and tags are kind of a ubiquitous generic mechanism for putting metadata on objects. I guess that's the most abstract way of saying it. But what we could do is that once TLS HD has authenticated a peer and trusts the certificate it's presented, then it can paw through that certificate, which is actually a lot of text-based information, and match some based on some characteristics in the certificate. Since we trust it, we can do simple string-based matching on it, and then assign tags to that TLS session based on what TLS HD has found in the certificate. And then other kernel TLS consumers can look at the tags and compare the set of tags on a TLS session to, say, a set of tags that are specified on some resource that we want to authorize access to, like an export. This is not rocket science. It can be complex to implement, but it's not rocket science. It's something that a lot of cloud providers do. It's not an uncommon way of approaching this problem. So as an example, say an NFS client is doing a mutual TLS authentication. It presents its X509 certificate to the server. TLS HD then has a bundle with a trust chain in it. It can authenticate that certificate and say, yeah, I recognize this client, and I trust that the contents of the certificate are valid. They're verified. They're cryptographically verified, and so I can trust what's in the fields in the certificate. So at that point, then TLS HD can walk through the fields, look at the subject field, it can look at the issuer field, it can look at the signature field, and it can trust that the text in those fields is something that it can base authorization decisions on. Then based on local configuration, that is, like some export might have a tag called Bakeathon, for example. TLS HD tags the TLS session, and makes those tags available to the kernel to use to do authorization checking in the kernel. So the way I figured that we ought to do this is, it might be a little complicated to explain, but essentially what TLS HD will do is implement filter types, which define A, what field in the certificate is it going to be looking at, and B, what is the pattern is it going to use to match that field. So, for example, I might have the subject field in the certificate. That's a filter type, and then I can define a filter with that filter type, and specify a pattern, just a wildcard pattern, so that whenever it encounters, like in this example, if it encounters a certificate that contains O equals Monsters University, then we could say that it's matched the Monsters University filter, because it looked at the issuer and it sees that the issuer is Monsters University. So we can have a mechanism by which we can define a number of these filters based on the field that we're looking at and the patterns that we're looking for. And then we define the tags, and the tags basically just a list of filters. So, for example, if I want to assign the ROR, the Roar Omega Roar Monsters University chapter to um, if we want to apply that tag to a particular session, then it has to match the Monsters University filter, the Fraternity ROR filter, and not be Fear Tech. Fear Tech is like, say, a filter that matches the issuer Fear Tech. So I have both the ability to positively match a filter and the ability to ensure that the filter is not matched. It inverts the sense of the filter. So in order for that tag to be applied to the session, all of the filters expressions in that list have to match. So Monsters University has to match, Fraternity ROR has to match, and not Fear Tech has to match. So, and that's how the tag is assigned to a TLS session. So you may have noticed that I spelled these things out using YAML. And in fact, that's exactly what TLS HD will, where and how these tag and filter definitions will be stored. They'll be stored in basically YAML documents under the directory etc TLS tags.d. And each one of these files can contain one or more filters and tags. So you can kind of arrange these things any way you like. And then this on the second half of this, after TLS HD is done with its filter matching and is assigned the tags to the session, when NFSE goes to look at what session the NFS operations in the session are trying to access, I added two new export options, allow tags and deny tags. So if it sees one or more of the tags in the allowed tags list on that TLS session, it will allow access, it will authorize access to the export. And if it sees one or more tags in the deny tags list, then it will deny access. This is a common sort of API designed for security and authorization. We don't have to do it this way. We can just have a single tags list and only match on the tags that are on the session. I don't know. This is just sort of something that our security guys hammer into us to have both an allow and a deny. A whitelist and a blacklist if you want to use the older terms. Go ahead.
So if you have an allow and not a deny, is there an explicit deny? I think there's like a precedence thing that has to be defined.
So I think the deny tags are looked at first, and then the allow tags. If there's no to deny tags list, then only the allow tags are looked at.
So there's like an explicit deny all, and then allow. Like,
I guess that's the way it would behave. Yeah.
Okay.
Okay, so there are some things that I recognize are missing. Probably the biggest thing that people are going to complain about right off the bat is that there's no filter type. There's a filter type for looking at the subject field. There's one that looks at the issuer field and some of the other fields. There is no filter type that looks at the subject alt name. That subject alt name contains a huge variety of different subfields. I put up here kitchen sink because that's kind of, there's a list of like 10 or 12 different subfields that are already defined in the standards for this field. So it's complicated to match. But what people might want to be looking for is DNS labels and IP addresses. That's how they're specified in certificates. But as I kind of felt like, we're already well beyond DNS labels and IP addresses here. We're looking at essentially, whatever is normally in a certificate that a client presents, that would be subject and issuer. Some people might say what we really want to do is match, have a tag that matches on the socket's peer name, the get peer name returns the IP address. And again, that's really something I'd like to get away from because that could be spoofed. So I'm not really sure where I want to go with this. So it might be missing. It might not be. I don't know yet. People are going to have to give me some technical feedback on that. Are there any questions or comments on this? What do people feel like it's too complicated? And you feel like you have specific ways you could simplify this? Maybe, I mean, Olga complained when she saw some of this that, a text file really, but it's like you can build a tool on top of the YAML and treat the YAML files as simply storage. That's the storage format, and then build like a GUI tool on top of it that helps people construct filters and tags, and they don't have to, worry about all the YAML nonsense. But I feel like that was something we have to do in pass one. It doesn't feel like an MVP feature. Any other questions or comments about this? Did I totally go off the rails, or is this what you had in mind, Ben?
I just had the original basic idea because I worked a lot with web stacks that do this and HTTP headers.
Yeah.
And I know that some of the problems there, configuring web servers have a lot to do with the allow, deny ordering. And especially when you first apply authorization rules, even if you have like a single allow, it all of a sudden causes a server or a system to implicitly create like either wildcard denies or no denies. And I think we have to be careful to get that right before we have existing systems out in the real world setting this up. And then we can say, oh, we have to change this.
Agreed.
I know you've already talked through all of that sort of thing.
But you mentioned that the allow and denies there are pretty complex, right? They have multiple layers.
Yeah, they have
Instead of a
multiple-
single layer here, like a two layers really. You have allow and deny.
Yeah, we have like allow tags and deny tags, but the situations that I can think of are when do you end up in both the allow and the deny situation? What are those?
Yeah, so maybe it doesn't make sense to have both.
And then, I mean, it makes sense as long as you can define exactly what happens when
Right.
in those
And
conditions.
yeah, I think you're right. You just need to spell out what happens, right?
Yeah.
Which one takes precedence, right?
Right.
Or I could say you can only specify either allow or deny. In the sense that if I specify deny tag, everybody gets access except for these tags. And if I specify an allow tags, then nobody gets access except for the
Yeah, because you could kind of push the complexity of making those decisions happen up into the user space portion, like into TLS HT. Like use a different tagging scheme. And then the other thought I had was subject to alt name is rough because I think you could have multiples in a certificate. Yeah. So then you could also end up with rules
It's
that,
only one field, but you can have a list of subfields in it. Is that what you mean?
yeah.
Yeah.
So then you can end up, and that's different from like the CN or the OU, because then your rules about matching you can match both ways, even if it's the same situation.
Yeah, I guess one way of dealing with the complexity of subject alt name is to add another dot at the end of it and put the subfield name as well, and just make those separate filter types that all filter on the same field. So I have a subject alt name, I have an x509.tbs.subject alt name.tns, and that only filters on, if there's a DNS element in the subject alt name list.
Oh, that's right, because they have like a tagging, they are their own format, Yeah.
Even worse, subject alt name has its own OID scheme. So if you're not using one of the standard subfields, you could make one up and you say OID equals blah 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 blah. So Rick yesterday asked me about how I'm going to do the feature that FreeBSD has now, where if the client certificate has a subject alt name field in it that has a user squashing instruction. And how am I going to do that in NFSD? And I would basically teach TLS HD to recognize that OID and maybe put a tag on or some other special netlink protocol element so that it could tell the kernel please add this user squashing instruction. So basically, this would provide the infrastructure for that support, but it doesn't actually implement it yet.
So Tigran has his hand up.
Okay.
Can't see it on the screen.
Yeah, all I can see is my slide. Go ahead, Tigran.
Okay, good. Thank you. First of all, I'm very glad to see you all again. Unfortunately, I cannot make it. Maybe in spring, we will see. Look, Jack, you still solve the problem of authorizing the machine. This is what the Mostly is doing, which is nice if you don't have shared resources. So we are looking more in authorizing single users and not the machines. And we have implementation for TI RPC, which supports OpenID Connect tokens over RPC. We kind of took whatever Kerberos is doing, reused the handshake to transfer the token to the server, and then server validates the token, and then as we have a TLS, so it's possible to do now. I was hoping that I will be able to implement in our server as well, and being able to demonstrate during the Bakeathon, but unfortunately didn't work that well. But we already have implementation for TI RPC for client and server sides. So we will try to document this. I already started a couple of years ago trying to make this problem statement draft, but we will try to as well document whatever we did as an implementation and then try to push it as a spec, because this will allow authorize single users independent where from they're coming. And well, you still might be want to restrict the number of machines, but for us, when you have a shared infrastructure, you want to authorize single user for access. So we are doing only identity tokens. So we are not using scope for authorization, so it won't replace the export, but at least, or access rights, but at least we know who is on another side, and then allows the server to do the proper mapping. So technically one-to-one, whatever is Kerberos doing.
Right. So TLS is definitely totally out of the business of identifying users. The user squashing thing I mentioned is basically an instruction to the server to handle it outside of TLS.
Right.
It's kind of a sideband communication, if you will. So yeah, you definitely have to handle this more like Kerberos than we are doing with the transport layer stuff. I'm really happy to hear that it's moving forward, and I am enthusiastically looking forward to seeing an internet draft, because I know there are other people who I talk with regularly who are very interested in OpenID user authentication in RPC and NFS.
Right. So we try to push this. So as I said, unfortunately, I am unable to demonstrate this time, but our code is there. It's public, so it's still not in a shape that somebody can use it, but at least we can demonstrate that it works. So we can do RPC ping to the server and get a response back and do the handshake and have a token on another side and authorize. This, of course, far away being implemented on a server side, especially that this all have to have some user space part on a server side to validate with IDP signature and all these things.
Right. Yeah. So you're solving a problem that we weren't trying to solve with this TLS session tag. And there are all kinds of use cases where you would use TLS along with Kerberos, for example, or with OpenID. If you want to have fast encryption on the wire, you could use TLS and then use OpenID to cryptographically authenticate your users.
Yes.
Okay, any other questions, comments?
Olga? You are muted.
Oops. Hi, folks. So Chuck, I'm still confused. Can you restate again what problem are we trying to solve by doing this? Because you're not trying to do authorization, right?
Yeah, we are.
Yeah.
Yeah, I mean, what we're trying to do is replace, supplement or replace the current NFSD implementation of authorizing access to exports by particular clients. And instead of using an IP address that can be spoofed or a DNS name that can be spoofed, we'll use the certificate, the X509 certificate that comes as part of a TLS mutual authentication.
So I understand if you're trying to use so the IPs and DNS can be spoofed, great. So if we're trying to use certificates to solve the the spoofing an IP address by basically securely saying, well, whoever has the certificate, has this particular IP or DNS name, that I understand. But going beyond, but you said that's not all that you're trying to do. You are also trying to do authorization, and it feels like using these tags are not as like I mean, that's why things like whatever Tigran was talking about, like secure tokens, or attribute certificates, right? That are already spec'd out, that seem like maybe a better use. I mean, better way forward, because there's already specifications for it versus trying to, come up with our own.
There aren't specifications for RPC with these other forms of authentication. And X509 is very well specified, so I'm not sure what's missing.
I don't have a good answer to that, but okay.
Well, I can say after kind of 25 years using certificates to authorize users, we decided that was too complicated and moving away.
Right.
For tokens.
We don't want to use certificates to authorize users. Obviously, OpenID and those other technologies are better for authorizing users. But there are cases where, we want to create a trusted NFS client. For example, if someone doesn't want to use those forms of authentication, user authentication, they can simply use auth_sys as long as the server trusts the client. And this is a way of saying, okay, we don't have to rely on the IP address or the DNS name of the client. We can actually rely on the client presenting an appropriate certificate that the server recognizes as part of being in its trust domain. And in that case, the server can go, okay, well, I know who you are. I know who all your users are, and you can just use numbers instead of a cryptographic token to represent your users, and that's fine. It's an alternative. It's not meant to be all singing, all dancing, as we like to say.
It's really based around host.
It's all based around peer authentication. It has nothing to do with user authentication. It can protect user authentication, but it doesn't substitute for cryptographic user authentication.
No, but authorization is actually even like in a way worse than authentication. The authorization first requires authentication, and only then you
Yes,
can authorize, right?
TLS does that for us. TLS does that for us. TLS already authenticates the peers, and all we're doing is saying this peer is authorized to access these resources.
Right, but we're
that's-
creating our own, because it's not even like ACLs, right? It's this form of filters and tags, tokens. I don't know how to call it, right? Versus something which has been well defined. I don't know, like let's say role based, or some kind of access based authorization schemes that are present within X509 it's specifications, right? I mean, there's some mechanisms, the attribute certificates, they're X509 attribute certificates, right? That are defined explicitly to do this, role-based authorization mechanisms.
Well, there's nothing that says we can't do both.
Yes, I'm just right. I'm just questioning whether or not we looked at existing schemes instead of just coming up with our own, right? I guess that's where I'm going. That's my comment.
Send me a citation, and I will look at it. That's not a challenge. It's just I'm interested in more information.
Yep. I hear you. I'm just thinking out loud.
So,
Yes, sir.
my question is, how does this interact with like the TLS and TLS options? And that allow these up loud and non tags. Does like, if you have those, does that imply MTLS?
I think it would have to, because if you don't have a certificate to pass to the server, then it can't do this kind of tagging. However, we could add some filter types that filter not based on certificates.
Sure.
So,
Yeah. But for the certificate ones, I would imagine it has to imply
MTLS is required, yes.
Yeah, that might be interesting if you didn't do that and you didn't specify any TLS authentication and then added tags, you just might never get a tag.
Right, it wouldn't do anything.
It wouldn't do anything. So I think we have to have some pretty careful documentation there, or either that or have it, like when you specify allow or deny tag, then you would imply MTLS as well. Something like that. Yeah.
Right, and that would be the reason why you might have a user tool, a GUI tool or something like that can set up both the YAML tag and filter configurations and the export options all at the same time, and make sure that they're consistent. That makes it a lot less complicated. Okay, I can be done.
Hey, Chuck. Yeah. We're seeing that go in.
Already open slots for discussions.
Discussion.